see, it's recording. Cool. All right, good evening. We are going to look into more pandas basically. So I want you guys to get pretty much familiar with the pandas environment. I know like we touched on it last week, but since we'll be using pandas extensively, it's good that you get a very solid ground on it, especially when we move to deep learning, machine learning section. The more comfy you are with pandas, it would significantly help you with the data pre-processing, steps that are fundamental in terms of, when you do data science or machine learning. Okay. Okie doke. So let's go and import the libraries that we want to do. So importing the libraries. Well, I won't write that again. Import numpy as MP and import pandas as PD. Okay, so we have the libraries imported, and now we can like get on with sort of doing some practice. Now, I know last week we imported a data file like from Excel, but we are just going to work with basic pandas, yeah, so that you get a really solid understanding of it. So before anything, let's just go and create some dummy data and then see how we can form pandas series and pandas data frames. So I'm going to make a list called labels, and I'm going to say these labels are A, B, C, and D. Okay? Oh, sorry. Okay, so I have a list of A, B, C, D, basically strings, and I'm going to call it labels. Then I'm going to say a list of number. So my list of numbers equals, let's say 10, 20, 30. Okay, and then I'm going to say, let's form a numpy array as well. Yeah, so R equals np dot array, and we're going to just create a vector of just same numbers, 20, 30, and let's make a dictionary too. Okay, so dictionary with the curly brackets, key value pairs. I'm sure you're now familiar with this stuff. So A and then a B is going to be 20, and let's say C, we're going to make it 30. Okay, so far I've just created a couple of list of numbers, list of strings, a numpy array, a vector basically, and a dictionary with the values are more or less the same. Yeah, so let's see how can we go and start like making panda data frames and panda series. So first we try to explore pandas series. Now, pandas series are not really used that much in terms of you using them. So it's really the pandas data frames. But considering that pandas data frames are technically made of the pandas series, so pandas series are single dimensional. If you think of it as like a single column, yeah. While panda data frames are the entire matrix of the sort of data. But let's just become familiar with what the series are. But ultimately, we'll be only using data frames. So if I say pandas dot series, and that is with a capital S, guys, yeah. And I'm going to say my data equals my list. Okay. So if I do that, it creates a pandas series data structure for me. All right. So this looks like the first column of Excel sheet, technically speaking. Yeah. Now, once you use the dot series function, you can also index this data. So if I go and say pandas dot series and data equals What did I give it? My list, wasn't it? My list, not my list, my list. And then I'm going to say index. Okay, so index equals, all right, what am I going to give my index? We have created, these labels, yeah? So shall we go and do that? I'm going to say index equals my, was it labels? Yeah, was it labels only? Labels, sorry. Okay, what did I just get? Length of values, yeah, length of values are basic. Length of the values are not matching the length of the labels. Okay, so if you want to do that, you need to make sure that the number of your labels and your items in a list are matching, for series to go and form that. So what really we need to do is that we need to get rid of that. Okay, so I did this so that you understand that when you want to create series of data frames, it's important that the items you use match in terms of the numbers that you're using. Okay, otherwise you get an error. So again, now if I say labels, okay, so this is the difference. So before, I mean, we did the same thing. We made a series using my list, and on the column we got 10, 20, 30, but it was automatically indexed to numbers 0, 1, 2, 3, like a Python numbering structure. But if I use the index equals labels, okay, then it will go and use whatever I give as labels to fit into the index. But it's important that the numbers match, okay? So that's first thing to, like the basic formation of a Pandas series, okay? Now, we can also feed an array to this function, yeah? So far, here, we fed a list to the series function, right? Let's try to do the same, okay, exactly the same. This time I'm going to give, do you remember my array? Yeah, so that was my array. Now I'm going to feed the array into the Pandas series. Uh, okay, who dared to mute me? Okay, don't do that, please. All right, I'm sure it was a mistake. So I'm going to now use a array basically instead of a list. Yes, so I'm going to say pandas dot series, and I'm going to say data equals my array, yeah? And it does exactly the same thing, okay? Now, one thing, guys, you can even skip doing this, saying data equals that, okay? But as a beginner, or if this is like new to you, I would recommend that you start with using, the function like this, just so that you get a hold of how this is operating. So the series function takes in a data, okay, and then it processes it into formation of a series, basically generating a series out of it. Okay. Now the same applies here as well. I can just use index equals labels, and it would give the same thing. It would then use the labels, which are ABC, as labels basically for my data. Okay. Let me just see. So we had the dictionary as well, which are called D. All right, let's now feed the dictionary into the pandas series function. So pandas dot series, and we're gonna give our dictionary to it. Let's see what happens. Okay, exactly the same thing. Okay, so this was feeding a numpy array into the series function, and this was feeding a dictionary, the function. Okay, so now when you use a dictionary, when, as a input for the series function, as you notice, it automatically takes the key values and inserts them into the index, okay? And then the values basically go into the, well, like the actual column, all right? So that's one way of forming a pandas series directly from a dictionary, okay? So it's good to know that you can do that. Now, let me see. I think I'm just thinking, should we spend more time with this, or shall I just go directly into pandas, sorry, data frames, rather than spending time more on this? Because once you get, I wanted you to sort of have an understanding of, yeah, let's move to data frames now. So these are series basically, but you won't use them much. Hence why we're gonna now, let's shoot to the pandas data frames, okay? Okay. Now, obviously, we have imported pandas, so we don't need to import it again, basically in this notebook. Uh, what we're going to do is basically try to make a data frame using some random numbers. Now, I'm going to say from numpy dot random import random. Okay, we have covered this stuff before, right? So now I have the uh, imported random, so I can generate some random values to play with. So that's why we are doing this, okay? Now I'm going to say, let's just see what rand_n does, just as a refresher for rand_n, okay? And if we say rand_n 5 rows 4 columns, okay? So rand_n gives you a normal distributed set of random values, okay? With mean 0, and that's what we get. Okay, so that's just a set of random numbers that we are going to be playing with, yeah? So we are assuming that this is some real data. I don't know, it's been generated by a machine. It's generated through some data collection from wherever. This is our data, we are assuming, or numerical data. And now we want to convert this into a data frame, okay? So obviously we are going to be having some index, yeah? So let's say our data frame, we're going to say data frame equals pandas dot data frame, and please note the capital letters I'm using. So it's capital D, capital F. I've seen a lot of times the students, while they learn it, they keep, making a mistake of using the lowercase f, for example, and they go a bit confused as into what's happening. So definitely capital D, capital F, yeah? And we are going to say, let's just put these data. I mean, I can either say A equals this and then put A here, or I can just go and say rand n 54. So that's our data, which is technically going to be, well, it's not going to be exactly this because it's random, yeah? Unless we can set a seed, but it doesn't matter. So it's just going to be different numbers because I'm generating different numbers. Now for my index, okay? So for my index, which is going to be my row identity sort of icons, I'm going to say A, B, C, D, and E. That's right, isn't it? So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5. Yeah, that's okay. And for my columns, okay, for my columns, I'm going to give W, X, Y, and Z, okay? So I'm basically going to be doing this, yeah? And I think I'm going to get an error, all right? Let's see why would we get an error. So at the moment, the syntax is like this. I'm giving, firstly, that is wrong. So I'm giving my data, which is something similar to this, okay? Then I'm going to give an index, and then I'm going to give it columns, basically, yeah? Let's see if it works. Ah, index must be called with a collection of some kind. ABC was passed. This is one of those error messages that does not really make sense for especially beginners. Yeah, now the reason is, if you notice, when I used indexing before, look at that. They were separated, weren't they? Whereas here, I'm giving it all at once, you know? Let's see. I specifically do this so that, you can have a reminder of, previous stuff that we have done. Yeah. Do you remember the split function? Okay. Dot split. So what if I go and put dot split here? So you see dot split does that. Yeah. And of course I need to do this as well. Dot split. Okay. Okay. So now, so I've created my data frame. Okay. And I hope you understood what I did here. So I just used the dot split function, which we have seen before. And that was, I mean, I could have basically created this manually, but then again, I'm doing this so that, you sort of have a revision of what we've done before. So we have given this as the index, as the row names, and columns as the column names. Using the dot split, we create a list of these basically items. Let's see how does our DF look like. So we have technically, it's just like an Excel worksheet, yeah? So we have created the Excel worksheet like sort of data set. Now this is actually a data frame, okay? Where you have particular rows, you got columns, and in each column and row, you're gonna have some designated value, all right? So this is in a structure similar to just the Excel sheet or a CSV file that we imported. Like last week, we imported some data to train with Seaborn. Okay, so let's just treat it like that. We're gonna assume this is some really, important real data, yeah, that we're going to play with. But because it's a small compared to the large data frame that we worked like last week, it's more easy to sort of understand and grasp the concepts of pandas. Yeah. Um, okay. So let's see first of all how we can select each of these columns. Although I think we sort of touched on it last week. So if I go and say df, yeah, and I'm going to say w, let's see what do we get. So dfw, once I call the data frame that I've created, brackets, and I give the column name, it will extract that particular column, the entire column from me. Okay. Now, one thing, what is this? Is this a data frame? Because the whole thing is a data frame. But is this a data frame itself? So we can quickly test that by saying type and then dfw, and we get the output is a pandas.core.series. Yeah. So a single column that was extracted using this selection, it just brings out a Pandas series. He extracts one of the columns as a series out for us. But anyway, that's how you select your desired particular column. What if you want to pick, I mean, like this is your data frame, and you want to pick two columns from this. Let's say W and X, okay? So what you need to do then, pay careful attention to the difference, yeah? We're going to say df, and I'm going to open a bracket, okay? And I'm going to open a bracket. I think some of you might be thinking like this. So w and sorry, w and x, yeah. Oh, why do I keep doing that? Oh, that's weird. My keyboard was not working. Okay, W and X. Yeah, so let's do that. Oops. Again, another one of those errors that sometimes you may wonder what's wrong, what happened. So key error W and X, you'll be like, okay, well, I definitely have a W and X in there, so why is it not picking it up? Before we did a W, and it perfectly pulled out that particular column. Now the reason is that you need to pass a secondary bracket, yeah? So if I do that, why does it, why is I think one of my keyboard keys is not working. Okay, now I'm going to do it like this. Yeah, so df double bracket, and in the internal bracket I'm putting the column names, and we get that. Now let's do the type again. Yeah, so I'm going to say type, so I'm going to put type, and I'm going to put this. Okay, what are we going to get? Pandas.core.frame.data frame. It's actually a data frame structure. Yeah. Now, what's cool, and I'd like you to appreciate, is that if I went and I selected DFW, do you recall that? Yeah. This was, of course, a series. I can even go and yeah, definitely my keyboard has raised the problem. That thing doesn't work. All right, df a single column but double brackets, and let's just check the type. It's a data frame. Okay, now at the moment this may sort of, you may wonder, okay, what's the point? I mean, like, okay, series data frame, what does it matter? To be honest with you, at this stage, if you just want to use pandas for visualizing your own data on the screen, it doesn't make difference. But do you know where it makes difference? When you want to process this data, when we go to machine learning and deep learning. Okay, because let's take a look. Okay, so first of all, or DF, yeah, or data frame. Let's check the dimensionality of it, or let's check the shape. Yeah, 5 rows and 4 columns, which is exactly what we built it on, basically. Yeah, so we generated some random numbers, 5 rows, 4 columns. So that's the shape of our data frame. Now, if I set df w, okay, dot shape, if I do this, what do you see? It's like working as a single vector. Sorry, my kids have come in the office. Let me just push them out. Give me 1 second. Atusa! Maman! بیا برو بیرون. ماما اینا اومدن وسط که آتوسا! بیا ببر اینا رو! بلند شو برو. بلند شو برو بیرون. برو بیرون. کلاس هم قطع کن داده. برو بیرون ده. نفهم. Sorry about that, guys. My kids had just popped into the room. Okay. Anyway. So df bracket a single column, okay, dot shape, it's 5-1. But remember, this was a series, yeah? Remember, this was a series, okay? Okay. Now, if I go and say df double bracket w, and then I do shape, do you see the difference? It now suddenly has a different shape to it. Why is this important? Well, later on, when we go to use TensorFlow and scikit-learn, these are the libraries that I will introduce to you for conducting machine learning models and deep learning models. You will basically realize that it's so important to notice what sort of shape of data you're feeding into it. Okay, so it will make sense then. So at the moment, all I want you to know is that it's important how you go and pick out a particular column from your data frame. Okay, if you use double brackets, you get it in multi-dimension, basically, well, two-dimension in this case. If you do single bracket, you pick that column as a vector, as a, an array of numbers. And of course, for selecting multiple columns, you have to use double columns. Okay, you cannot use a single column basically for that. There is another method of calling DW, but I don't recommend it. I just show it to you, but I recommend you not doing it, and that is df dot w. Yeah, what I'm gonna put here. Please try to avoid using this until much later on. Not even until much later on. Do you know what? Just don't do it. Yeah. It's not a good method. It just gives you that, yeah, but it's not a good method. You will see some coders do it, but in my opinion, it can lead to some silly mistakes in future that then it becomes a bit complicated for you to sort of identify where you've gone wrong. So while you can do this to pick up W, just avoid this. Okay, so I just showed it so that you know it happens in case you see somebody else's code or something, yeah, but don't do this. This is the much nicer, neat way of doing it, dealing with data frames using the brackets. Okay, so only use the BRAC model, BRAC way of doing it, yeah. Anyway, now let's go and do some operations with our data frame. So we have this data frame, okay. Let's do some basic mathematics. Now imagine that we want to have a new column formed, and in this new column, these are the sort of stuff that you can do easily with Excel as well, yeah? Except that if you were to do these things in Excel and then bring it back for your machine learning model, it just takes time. So rather you want to do it right, as you're coding, okay? Besides, especially if you write algorithms that need to update or create a data frame for you, you can't go to Excel. You have to do it in this environment. So let's say we want to add W and X together, okay, and then name it as something, let's call it df new, okay, df new equals we're going to say df w plus df y or x, whatever, x. Okay, so we are going to be adding these two columns together, okay, and look at that, we are saying df new. Okay, let me do that now. All right, fine, so we've done that, no output yet. Let's see how does our df look like now, because it's updated now. So if I call df, there we go, a new column is formed permanently where it illustrates the results of adding w and x, which I think w and x, wasn't it? Yeah, w and x added. All right, and obviously you can just do more additions if you want to add the whole lot basically or whatever, but for the moment that's what happens. Now guys, this is another sort of mistakes that I've seen, that the students think that, oh, so how about if I just come and say, I don't know, df2, another df, yeah, new equals dfw plus df no, df x. I mean, this is a mistake that I just want to warn you of. So if I do that, I'm going to get what? df2 is not defined. Okay, df2 is not defined. So I'm getting an error because it won't matter much because df2 does not exist. Okay, it's important to note that sometimes when you write an algorithm, yeah, imagine that you had another df which was df2 with similar size, yeah, with similar size. If by mistake you happen to choose the name of your other data frame and you do this, the operation would run and it won't give you any error, but your original df, the one that you want to add this new column, won't be affected, and the other one would suddenly have a new column popped into it. Now, would that harm you? Well, it depends case by case. So the point I try to emphasize here is that always when you do this sort of operations with pandas, ensure that you are using the correct data frame name. Again, here it may not sound much, yeah, like you may be like, why would I ever make that mistake? You know, why would it ever happen? At the moment we have this df, why would I use df2? Well, it would occur later on that through your code, you're using data, multiple data frames, you're updating one data frame, you're extracting data from one data frame, you're doing really exotic stuff, and then one mistype, you suddenly end up updating or changing another data frame. So pay very careful attention to these concepts right from the beginning, okay? Even though at present their significance is not really highlighted as such, okay? Okay, so let's say now that let's say we made this new one by mistake, or we applied some function that this was a mistake and it didn't generate the right numbers, or we just made this other mistake that we updated it on a different data frame or whatever. In simple language, let's say if we want to get rid of a column, okay? So how do we go by getting rid of a particular column? Now, the function you use to get rid of a column, yeah, the function we use the drop function, okay? And the drop function works by calling it on the data frame, yeah? So our data frame df at the moment has 5 columns, yeah, with the last one being new, which we just added to it. And let's say we want to drop that new. So I'm going to say df. Let's just look at df first. So that's df, yeah? And we want to drop new. So you're going to call the dot drop method, okay? Parentheses, and okay, drop what? So we're going to drop new. So you give the actual column name. The name needs to be the perfect exact match, yeah? Always with pandas. Just a reminder, the name of the columns need to be exact match in terms of everything, higher uppercase, lowercase, I don't know, spacing, whatever you call it, yeah? They need to be always matching. You can't come and say drop new, yeah? You can't do that. It needs to be the same name. So okay, let's do it, yeah? So df.drop, and what did I get? New not found in axis. Okay, how did that happen? Definitely we had df new. So df.drop new. Did I do something wrong, guys? Let's just double check. df. Okay, so definitely there is a new in there. why am I getting not found in the axis? Okay. The reason is when you want to drop a particular column, not only that you need to give the name of the column, you need to also illustrate or demonstrate in the input function of drop that which axis it has to go and fetch this from. Okay, so if I come and say df dot drop, and I'm going to say new, okay, but I need to say what? Axis. This is important for you to pay attention to. When we want to refer to rows, when referring to rows, it's the axis equals 0. And when referring to columns, yeah, it's axis equals 1. Right? So now what I'm going to do put here is axis equals 1. Right? And he has dropped it. Excellent. Yeah. So we just went and dropped the new axis from our data frame. But hold on a second. Yeah. So we've done this. We are assuming that we dropped the column, and happy doopy, we have W, X, Y, and Z there. Now suddenly, if I come and say df, it's back there again. So what happened? I mean, definitely I ran this. I mean, let's just run it again. There you go, it dropped. But I'm just calling df again, and it's back there. Now the reason for this, yeah, it's because dot drop does not perform a permanent modification unless you tell it to do so. Okay. Now there is a case that you can go and say df2 in fact equals df dot drop new, okay, and then I'm going to say axis equals 1. Okay, pay attention. If I do this, it's okay. And guess what? Now I'm going to have a df2 which doesn't have that column, but my df1 remains as the original one. There is a case that sometimes you may want to keep your original data frame. Yeah, very important, guys, to pay attention to. Sometimes when you want to get rid of a particular column, you do not want to affect your original data frame. Rather, you are going to generate a new data frame from your original data frame after having dropped a particular column out of it. And that is when you assign this. So you say df2 equals df.drop new and axis equals 1. Okay. Now, if you don't want this, and I would say this is the right way of doing it, especially when you work with large data frames, like when you have a big project and you got a really complicated data, and you go and use pandas.read CSV or Excel or whatever, and you import this data, and you're about to start doing some pre-processing, you might be suddenly wondering that, oh, okay, I have a couple of columns here that are garbage, like I don't use them, I don't need them, so let me just drop it. Really, the good practice would be to um, would be to generate a new data frame from the original data frame when you are dropping these columns and all that. Because in case you make a mistake and you drop a particular column by mistake, if that has been your original data frame, then it means you need to go all the way back to the beginning and import the data. And trust me, sometimes these data frames that you need to import are quite large. Like I have a data frame like for one of my physics stuff that it takes about 20 minutes to upload it. Okay, seriously, 20 minutes to upload the Excel sheet into this because it's ginormous. Okay, and just imagine if I drop a column permanently and I realize that, oops, I made a mistake, it means I need to wait another 20 minutes to do that. Whereas if I use this method and I say df2 equals df the original dot drop that, if I've made a mistake, well, no problem. I still have my main data frame imported. So I just correct this and generate the new data frame correctly. All right. So firstly, bear this in mind that maybe this is the rightest approach when you want to drop something. Unless, anyway, you want to drop it from the original one. But if you insist on having a column dropped from your original data frame, then, as we said, you need to tell it. Yeah, you tell it. So, and how do we do that? Uh, how do we tell pandas to do so? By using in place argument. Okay. So what is the by place in place argument? It just is basically going to say df dot drop and I'm going to say new. Okay, and of course I define the axis. Sorry, but this is getting me worried. My cursor keyboard is not working. New and axis equals 1 and in place in play in God in place equals, I'm going to say true because by default in place is in false. So if I do that, okay, that's it, it's dropped. Now I'm going to call the data frame and you see that new is now permanently gone. Okay, so that's the way if you want to change the data frame. If you want to change the data frame, well, delete a particular column from your data frame and you want it to be permanent. You use the in place argument. All right. How about if we want to, shall we go and drop a row as well, just so that we basically, have a hold of that as well. Let's go and drop the last one. So if I want to say, let's say we want to drop ef dot drop, okay, you're going to say except that. So here, let me just write the note. Here we are trying to drop a row, okay? So if I go and say again df.drop, do you think if I don't put the axis, am I going to get an error or not? Let's just see. Wow, it did it, okay? And of course, he has done it not permanently, but you might be like, Ali, you told us you need to define the axis. Well, because the axis is already defined in it by default to be set at 0. Hence why when you want to drop columns, yeah, you use axis equals 1, whereas when you want to drop rows, you don't have to, okay, because it's already set at 0. But as a good practice, you would do this, especially as a beginner, so that you remember this. But then later on, when it becomes, when you become familiar with it, then you don't need to do it. So if I just do that, that's fine. It's done. And of course, if I want to drop it permanently, okay, I'll have to, what do you say? If I want to do it permanently, I would have to put in place. Yeah. So the same thing applies. Actually, I wanted a code here. Just remember, if you want the row to be removed permanently, again, again use the in place argument equals true. Okay, so that's that. Now again, let's go back and check out something. So that was our df. We know now that if we wanted to pick one of the columns, we go like w, happy to p, we get a column. So just recall, this is how we picked columns. Yeah, if you want to pick out a particular column because we want to do some calculation, or we want to feed it to a function, or we want to do something, yeah, doesn't matter. Picking out a column, it was df bracket column name. Okay, and definitely works perfect. Okay, what about rows? So how about picking rows? Okay, I'm sure some of you would be like, well, that's piece of cake. You're going to say df.w. What rows do we have? Is it A, B, C, D? Yeah. So I'm going to say A. Okay, there we go. Ah, what happened? What's the error? If we have a, oh, you see again, this one of those error terms that does not make sense, yeah? And I'm going to leave the error here. Now the reason is when using, when just, yeah, when you want to pick rows, you need to do something extra. Okay, and that is you need to call the dot lock function. Okay, and I need to do the pound sign. Okay, what's the dot lock function? So I'm going to say df. Okay, df dot lock, locate. Yeah, dot lock means located, and then I'm going to put the bracket. Then I'm going to put a. Okay, and then it gives the row to me. But look at the structure of the row. Let me just do the shape. No, sorry, that was my bad. Okay, 4 rows basically. All right. I want you to pay attention to what happened, guys. Yeah. So let's just call df. Look at df. Okay. How many columns do we have? 4. 1, 2, 3, 4. How many rows do we have? 5 rows. Okay. So if I set df w dot shape, I'm getting 5. Let me just put this df up here as well. That would help. So the shape, this is I'm picking the row. Okay. I'm picking the row with using ilock. Row selection. And that's column selection. So I think this is pretty simple to understand. You just need to use the dot lock. It just is the shape I want you to pay attention to, yeah? When you pick the row, and you select it, as I just showed you, df.lock a, remember, it's like as if it creates a series, okay, that the values are now in a column. Again, this is one of those things that I want you to just learn at the moment so that later on, if we come to it, you do not get confused regarding the shapes, yeah? Okay, so it does not generate suddenly a row of numbers because A happened to be a single row at the time. It actually gets and puts these into the rows of a column. So suddenly it becomes 4 rows and a single column. Just appreciate that at the moment. Know that what it does, okay, for a later on, like so that when we go over it, you do not get confused. But just learn that. Otherwise, just choosing a row, you use dot lock. Choosing the column, it's a simple bracket and, like what do you say, the name of the column. Now, if you might be like, what if we had a data frame that did not have, like it did not look like this. It did not have these items A, B, C, D, E, as the rows, yeah? How do we go by basically picking this particular row, yeah? The way you do that is that you can say df, okay? So if you need to pick rows based on their numeric position, okay, then you need to use the dot iloc, yeah, standing for index location, okay. Come on. So let's say we want to pick B. Yeah, so I'm going to say df dot iloc, okay, and I'm going to say df dot iloc. Well, this is going to be 0, 1, 2, 3, 4. So 0, 1. Let's just say I'm going to say 1. Yeah, it picks out B. Okay, if I say pick 2, it's going to pick C. So you use iloc if you want to choose the rows based on their numeric position. Okay. If you want to select, now what if we want to pick out a single number from the data frame? Okay. Again, I have to keep saying this. These are one of those things that at the moment it seems nonsense, like why would you want to do that? But then you will realize that later on you actually tend to use these sort of operations quite a lot, yeah? So we want to just pick out a single number from this. So if I go and put here df so we can visualize it, see it. Okay, so that's our df actually. That's our df. And if I want to go and pick, let's say this number, okay, let's say I want to pick this number here. If I go and say, sorry, let me just mind. Sorry, a bit of coffee. Okay, so I'm going to pick that number. I'm going to say df and I'm going to say lock, okay, I'm going to say df and lock, and then I'm going to put the brackets. So I'm going to say row, was it this one I said? Yes. So C and X. I'm going to say C and X. Okay. So df dot lock. Let's see. And it picks out this number for me. Okay. And if I want to take a chunk of this data frame. Okay. Let's say I want to take a chunk of this data frame. So how about selecting a chunk of the data frame? Again, something which will be extremely useful in future. I mean, you would be using it a lot, but at the moment you might be like, oh, why do I want to do that? You'll be like df dot lock. Let's just select where we want to pick. Okay. Let's say we want to pick B and C. Let's say we want to pick this bit. Well, this bit -583987 we want to take this chunk out. Okay, so the way you do that, you need to now go at first the double bracket. Was it B and then was it C, yeah? C, okay? So that we are telling it which rows to go for, okay? So far we are telling it go for these two rows, right? But then we're going to say now which columns do we want? And we're going to say, was it Y and Z? So Y and Z, okay? So if I do that, it now goes and picks out that bit of the data. Yeah, -5 and then 539, -58, 539. So that's how you do a selection of like a chunks of your basically data frame. You can also do this using the iLog, okay? You can also do exactly the same thing with iLog. And the way you do that, you can do that using iLog, iLog as well, okay? And the way you do it is that df dot iLog, okay? Now, when you use the iLog method, you need to use numbers, okay? So df.ilog, let's just look at that, yeah? Let's see what does this give us, okay? So I think this way it would probably make more sense to you. Okay, df ilog, and I just use semicolon, comma, semicolon, and I'm getting the entire data frame, right? Okay. What if, I think this is a better way for you to understand. So first you try it with this. Now I'm going to say I want row 1, row 2, and I want all the columns associated. So I'm going to say df dot ilog. What did I say? I want rows 0 and 2. So start from beginning up to point 3. Do you remember indexing, with lists and all that? Yeah. So start from beginning. This is referring to rows, yeah? The first section. This first section refers to rows. The second defines the range of the column. So I'm saying go up to 3. 0, 1, 2. Well, actually, I should say 2 isn't it? Because we just want the top 2. And we want all the columns associated with them. Okay, so df ilog 2 and then all the columns. What if I wanted only w, x, and y? Then I would be like, then I will do this. So we want just w and x. So 0, 1, 2. Well, we're just going to say up to 2. You see what happened? It picks that up. Can I ask you something, guys, which is super important? Because when it comes to your data pre-processing and machine learning, you will be using, let me write this here. Trust me, you will be using this form of indexing so much, okay? While it's simple, you will sometimes get confused with it, okay? So please try to, after this, after this lecture, try to spend some time using this technique, practice as much as you can, and try to select different bits of this data frame using this method, the iLog, and giving the locations. Try to choose chunks of it until you get a hang of the idea. So the concept is the same thing, but really in deep learning, machine learning, you will be using this mainly. Okay, super, super important. All right, that you become really comfortable with this method of indexing. All right. Anyway, so I assume that you will be going and, doing a lot of practice with this. Now, let's move into something more important. Okay, now that we have that, let's look into something really important, which is called conditional selection. Okay, conditional selection. All right, so what is this conditional selection? So let's look at our data frame, or little tiny, data frame that is handy. It fits in one page and we can quickly see everything. We have all the values here. What's going to happen, guys, if I use a Boolean operator like df bigger than 0? What did I get? So I'm getting a data frame, but with true and false values. So this is the df, and I'm saying bigger than 0. Is this bigger than 0? So it goes the element wise. Every single value in this data frame is checked, and if it's above 0, that location, okay, that location becomes a true, and if it doesn't meet that condition, it becomes false, okay? But bear in mind, once we do this, this output is only in the notebook environment. We haven't saved it as anything, yeah? If I call this bool equals, yeah, oh, I shouldn't have done that. I did something really bad. I shouldn't have done that. I hope it doesn't cause problem later, because bool is a Python function itself. Anyway, I hope not. So boolean is the Boolean function, yeah. Sorry, boolean is the data frame that is generated, provided that if the original df, the original data frame, was meeting a condition, like values being 0, right? So you can do that. But let's just go back. Let's just go back to our df above that, and then I'm going to just get rid of that. Okay. So this is a condition that we have. Yeah. Here, technically speaking, here we have illustrated a condition. Okay. Now what we want to do, we want to impose, yeah, so what we want to do, we want to impose this condition on our original data frame, okay? We want to impose this condition on original data frame. So our original data frame is this. Now, the way you do it is that you're going to open a bracket and you put your condition here. So let me write that here. The way you do it is you put your df, and then you open the bracket and you put your condition here. Okay? So if I put df here and I put df bigger than 0, okay? Let's see, what do I get? So suddenly, if you notice, it went there, and anything that was false converted into a non-value, okay? Anything that did not meet that condition that I imposed on the data frame suddenly gets converted to a non-value. It's like as if it removes them. And we are only left with values that are basically were meeting that condition. Okay, so this is the most basic form of setting up a condition in there. Now let's try to get it more exciting. All right, let's just see what else we can do with this conditioning. So again, df, that's our condition, and we have wxv. Let's see if we say, what if I say df var dfw, okay, we know dfw is this. What if we set the condition that this is bigger than 0? What do we get? Let's take a look, guys. This is, I really want you to pay super attention to this if this is new to you, yeah? So DFW, we had positive number, positive number, positive number. Oh, we had one negative number, okay, one negative number, and then a positive number. So if I was to say DF W, DFW is bigger than zero, what would I get? I'll get a Boolean sort of data frame, wasn't it? We already discussed this, yeah? Now I'm imposing this condition on the original data frame, okay? So I'm imposing this condition on the original data frame. And look what happened. Do you see this row D? It's completely is wiped out, yeah? Because in this method, what we were saying was like as if we were saying we want our data frame, original data frame, but we want it such that any row or anywhere that DFW was less than zero to be removed, or otherwise we just want DFW to be above zero as a condition for our original DF. So if we'll go there, check out and see if the condition is met, it would be like, all right, I will keep this. So yeah, I will keep the entire thing. I will keep the entire thing. I will keep the entire thing. Oh, this is not meeting the condition. So that's it. I'm going to take the entire row out. Now, this is again one of those super important operations that we will be using later on. It's used extensively during your data pre-processing. For example, if your DF, like your W column, is a particular column that if its value threshold is below zero, like if it's negative, it means everything else is not valuable, or like the data is flawed, or like there is something wrong with it. So with this simple condition, you just get the entire row of data cleaned out from your code. You can imagine at the moment this is a small data frame, so it makes sense. But this would become super handy when you are dealing with massive data frames. Okay, so this is what's called as a referred to as a conditional selection. And then you can also do stuff like this, like for example, let's just pick out column Z. So we know that this just generates a data frame. And of course, you can assign these, yeah? So you can say, I don't know, something equals this, yeah? I'm not going to do it here. And that's what you usually do. So if I again use this, so I'm selecting DF and I'm putting a condition on it, and I'm going to say select column Z from that, yeah? Okay. So I will now go and just fetch that section, that bit out. These are all the stuff that I really like you to go and try and practice later. It's so important that you get a hold of this and you understand basically what we are doing here. At the moment, again, it's not, it might not seem like that much of a cool thing to do. But if you don't learn these, later on you will significantly suffer. Okay, I assure you. I assure you that if you don't get uh, Y and Z, that's the Y, doesn't it? What did I? Oh, okay. Yeah, that's good. Let it just stay there. So yeah, if you don't get a hold of these, yeah, if you don't get a hold of these, you're gonna seriously have trouble later on when we go to machine learning, deep learning. So it's important that you play with these data frame structure, these conditional selection. They're really simple, but it takes a while for you to sort of, get the hang of it. Now, I'm hoping that you guys know why I got an error here. This is one of the earlier codes that we discussed. We tried to do this and we got a similar error. Of course, that goes back to the fact that you need a, and my cursor doesn't work. So that's right. Right. So I'm just using a conditional selection, and then I'm picking out from conditionally selected data frame the two columns. Okay. Uh, Now there is also when you can, in conditional selection, you can have and okay, and for arguments, yeah. However, I know you know in Python for and you use and, yeah, and is used for and, but pay attention in this case for pandas conditional selection we use and and this I don't even know what is it called. Yeah, this one or. Okay. Well, let's just do it so that you understand what I'm referring to. Okay. So if I want to say, let's look at our data frame again. So that is our data frame. I want to set up a condition where I want only part of the data frame where the W and X are negative. Yeah, shall we do that? Okay, so I'm going to say df, okay, and I'm going to put my bracket, and now I'm going to set up my condition. Yeah, I'm going to open a parenthesis. I'm going to say df bracket w, all right. I want it to be less than 0 because we want it to be negative. Now I'm going to put my, let me just first run this. Okay, so that gives me what? DFW. Okay, this is 0, right? Sorry, DFW is smaller than 0. How did that happen? DFW, yeah, so zero point 0.7. It's picking out this row, okay? Because that's the only place that DFW is 0. So it's picking out this row only. But what did I say? I wanted this one as well, where X is also 0. So I'm just separating these with distance so you understand how I'm putting the condition there. So I'm going to say df, okay, x, was it x I said? Yeah, dfx is also smaller than 0. Okay, so let's now run this. Okay, what happened here? Well, I'm putting an and, okay? So there is the condition here, this row, where DFW is 0. So it goes to select that, but because I've put an and here, it means it wants both conditions met. So it's basically going to eliminate the entire thing because the only place where W is negative is in row D, then, and the only place that column X is having the negative values are these last one and the first ones, but they don't intersect the rows. So, and since it's an AND operator, both conditions need to be met, and since they're not, it's going to just basically delete the entire thing. What if I put OR? Where was it? Okay. So now, what did it do? It's meeting this condition, so it's including D. Then it goes after X. This one is negative, so it's including A. And it sees in E, again, X is negative, meeting the condition. So it says, so as you can see, it chooses A, D, and E. Okay? These are, I would say, guys, these are going to be the most important parts of data preprocessing that you need to become familiar to. While at the moment, they may not seem much, yeah, uh, they become super important later on, yeah. They become so important that you cannot imagine, because a lot of your data preprocessing, data cleaning, when you want to get rid of unwanted data, you know, um, or when you want to restructure your data frame, you need to become super comfortable with these steps. So 100% today after this lecture, definitely go and practice with this. All right. Um, I want to just show you one last thing because there is other stuff that I can show you, but we don't have time, and I want to really like finish the lecture soon. So what I'm going to do is to just show you the how to deal with NA values, basically, yeah, with non-values, because that's an important thing. Now, do you remember we used something here? Okay, this df. Let me copy this. Okay, and I'm going to just write it here. Do you remember this, guys? So our condition was df where df is bigger than 0. Okay, so we're going to call this our df3. Okay, so our df3, we're going to just assume that this is a data that we want to work with. Whoever has generated this data has ended up, I don't know, maybe it was a questionnaire, maybe it was a machine taking readings or whatever. Yeah. Uh, and like there are missing values basically in there. Okay, there are missing values. So what do you want to do with missing values? Because missing values are a super important problem when it comes to machine learning and deep learning. Technically speaking, you can't train a machine learning model or deep learning model if you got non-values in there. Okay, because they're going to be generating errors. You cannot have non-values. You need to either get rid of them or fill them with something. So let me put this here. You cannot train AI models with data frames that have non, well, not like that, non-values. Okay? Definitely you can't. So either you need to get rid of entire rows or columns with non-values, or you need to fill them with something. Okay? That's what you need to do. Now to get rid of, let's go and try to see this. So if I say df3, and I'm going to use dot drop NA function. The name is on it. It's going to drop what? NA, non-values. So if I run that, what did I get? I'm getting only C, column C, and that's because it's the only column that doesn't have non-values. Okay? Uh, you may be at the moment asking me, oh, good God, like, so what are we going to do the machine learning with, if I suddenly drop this? Well, the very fact is that it all depends on how important the other columns are. Obviously, you cannot train a machine learning model with a single row. Yeah, that's not the case. But let's assume this was a data frame of, I don't know, 10,000 columns, sorry, 10,000 rows and 40 columns. And when you do this, suddenly from 10,000, you fall into 500 data points. But that clearly indicates that the data is not good enough. Tough luck. Sometimes, honestly, it's tough luck. If you don't have enough data, you can't do machine learning or AI, which means you need to go and generate or buy data or source the data or come from somewhere. Yeah. But there are situations where you can actually say that, well, I'm going to fill the non-value with something. If it makes sense. This is case sensitive, yeah? But let me just show you something else before that. df3 dot drop NA, and I'm going to say axis equals 1. Okay, what happened? So axis equals 1, everything is gone now. Yeah? Why do you think that was the case? So this was drop an A and just a single row came in. What is df? Maybe, I mean, like, shall we try axis equals 0? Dot drop an A, axis equals 0. And I remember I told you that 0 equates to dealing with the rows. So we're getting exactly the same thing. Well, we have already mentioned this, but this was just a reminder. So the axis that you use by default is set to 0. Hence, it brings the rows. What this means, it means drop an A based on looking into the rows. Okay? So it looks into rows, and this is the only row without any non-values. Hence, it brings it. But why do I get an empty data frame when I use axis equals 1? Well, because axis equals 1, it means drop non-values according to columns, meaning drop columns that have a non-value. Okay, this column has a non-value, this column has two non-values, this one has four non-values, this one has two non-values. So it goes and drops the entire thing. Okay? Super important that you understand this drop NA and the axis that you use when it comes to data pre-processing for machine learning and deep learning. Okay? You can set up a threshold, but I won't get into that now. Threshold means, for example, you can say that drop a particular column depending on how many non-values are there. We'll get to this later. I won't go into it now. It's quite simple actually, yeah. So let me, should I just show it to you maybe? Or, no, leave it for now. Okay, I don't want to get you confused. I want you to just become comfy with this. All right, so that's how you basically drop these values. But let's say there are occasions that you want to sort of add something. Yeah, you want to add some particular values in there. The way you do it, let's just look back into our data frame. Okay, so let's say we want to, sorry, df3 was it, yeah? So we want to fill these non-values. So we're going to look into filling the non-values. Now we don't care at the moment what to fill it. I mean, like, I'm not going into the mathematics of what we want to fill in there. Let's just say we just want to fill something so that you first learn the method. We're going to say df3 dot fill na, means filling non-values. Then you need to tell it, fill it with what? And I'm just going to say value equals, I'm going to give it a string. Shall we just say something? Okay. You see what happened? So you can use the fill a name method, okay, and actually, no, and fill something. Sorry, guys. Give me 1 second. Leo, baba اینو بفرست بیرون. آتوسا بیا اینو ببر. بیا لیو رو ببر اتاق من. Yeah, sorry guys, my kid was. Sorry guys. All right, I think I need to end this soon as well. Anyway, so we use the fill NA to fill the non-values with something. Okay. Now, let's just do one command. Of course, I will expand on these later, right? Because we'll be doing a lot of this in future. But let's say obviously you don't want to fill it with something. Yeah. Shall we say we want to? I'm going to just copy this. Okay. And for whatever reason, we think, yeah, that we want column W's mean number, okay, to be filled into those non-values. So I'm going to say that value equals df, okay, df, sorry, df3, I need to say df3 column A, and you all remember the dot mean function, okay. Oh, what did I do wrong? Sorry, W, I meant one of the columns. So yeah, I want to use the column W, okay, I want to use the mean of column W and fill the non-values with. Okay? What happened just now? So pay careful attention to these somethings, where we had somethings. It's basically now gone and filled the non-values with the mean of column W. Obviously, you can put various other mathematical operations here, but for today and this evening, this is just as good as much as we're going to basically expand it. So we learned that there are non-values, how to drop them, and there is functions and methods that we can embed within the fill NA to have these values basically filled in. But the idea of data pre-processing is such a big topic in data science and AI. Is super important because from case to case it varies, yeah? Where you would use mean, where you have to actually sacrifice your column and all that, or your entire row or many rows. They are really case dependent, yeah? But for the moment, if you just know that there is a fill NA and a drop NA method, that should be fine enough. Okay, guys, my kid is, I think, becoming a bit anxious. I need to go, otherwise he's gonna break into the room again. Yeah. Victor, I see you have a question. No problem. Uh-huh. Okay. Let me look into the latest. Drop me an email. Yeah. Drop me. Yeah. No problem. That's cool. I will try to send you a updated. I will try to send you an updated attendance list later on today or tomorrow. Okay. But yeah, drop me an email always. Don't worry about this so much, guys. Like, you'll be sorted on this. Most important for me is for you guys to learn this stuff at the moment. Okay. And Julio, did you have a question? No problem. Okay, Julio. Okay, maybe that's a mistake. All right, guys. So shall we end it now? Oh, thank you. No problem. Thank you to you guys as well for putting your time and, attending the class. I appreciate it. It gives me energy. Well, have a pleasant evening, guys, and all the best for now. Take care.